So we are given this question here, which gives us an integer array nums and three integers k, op1 and op2. So we can perform the following operations on nums. That is, we can either choose an index, divide that by 2, and round the value that we get after dividing the value present at that index to the nearest whole number, and we must round up that value. And we can perform this operation at max op1 times. And similarly, there is also an operation 2 that says that we can choose an index I and subtract k from the value present at that index if the value present at that index is greater than or equal to k. Again, this operation can be performed at most op2 times. And we also given that each of these operations can be performed not more than once per index. And also we can apply both the operations to the same index as well if we want to. So we have to return the minimum possible sum of all elements in nums after performing any number of operations. So we can see that we are having multiple choices for each element. That is, either we can apply no operation to that element, or we can apply the operation 1 to that element, or we can apply the operation 2 to that element, or we can apply both of them to a given element. So this can be modeled using a recursive approach that exhausts all the possibilities that we are given. So what we will do is we will create a function that takes the index of the number that we are currently looking at, the number of operation 1s that we can perform, the number of operation 2s that we can perform, and the value that needs to be subtracted in operation 2. And also we are taking the integer array as well. So what we can do is we can explore all the possibility that I just mentioned using recursion. So the first operation can be that we do not perform any operation on the given element. In that case, the element remains as it is and it will be present in our answer as it is, and we can move on to the next element without reducing any number of operations that we have. So the second operation is that we can perform operation 1 on a given element. So we will check whether we can perform that operation, that is whether op1 is greater than 0, which is indicated by an a here. And if that is the case, then this element that we are trying to apply the operation on will become the element by 2 and rounded up to the nearest integer. And this expression here gives us that value. And if we cannot perform this value operation, then the value remains as it is. And then we can again just move on to the next element, and we will reduce the operation of op1 that are available to us by 1, and we must make sure that they do not go negative. And similarly we will also do for operation 2, but there is additional condition on operation 2, that is we must have an operation 2 left, and also the element present at that index must be greater than or equal to k. If that is the case, the element is reduced by that number, otherwise we do not reduce it. And again we move on to the next element and decrease the number of operations that we have used of type op2. Similarly, there is a third operation where what we can do is we can first apply operation 2 on a given index and then apply operation 1. So for that to happen, we must have both of these operations left, and also in order to apply operation 2 firstly, the value at that index must be greater than or equal to k. If that is the case, first I apply operation 1 that reduces the value present at that index by k, and then I divide it by 2. That is, I apply the operation number 1. And then I decrease both the operations by 1 and move on to the next element. And one other way of applying these two operations would be to apply operation 1 first and then operation 2, which can be done by first applying the operation 2, the operation 1, that is dividing the element by 2 and rounding up to the nearest integer. And then we can apply the operation 2 itself, that is decreasing the value by k, if possible of course. And I'm just checking all those conditions here. And if yes, then I will perform that operation, move on to the next element after decreasing the operations of op1 and op2. And then I can return whichever is the minimum value, whichever gives us the minimum array sum after performing those operations. So this is the brute force way, and in order to optimize it, we can use memoization to store the results of the function calls. So we can see that we have three parameters that are changing in every function call, that is index, a and b. So we can define a 3D DP, and we can store that the first index can go up to n, the second value can go up to op1 plus 1, and similarly for the third value. And when this function is called, we will check whether we have previously computed this result or not. If yes, we will use that result. And when we are returning the result from this function, we will store that result in our DP array as well. So thanks for watching, and I will see you in the next video.